In this video here, we're going to take a look at resultant moments. Now, when we have several coplanar forces acting on a body, we can determine the turning effect around a given point by choosing a positive direction, either clockwise or anti-clockwise, and then finding the sum of the moments produced by each force. Now, typically we would take anti-clockwise as positive and clockwise as negative. You don't have to, you could do it the other way around, but it is important that you state which direction you're taking as positive. Okay? So to summarize here then, the sum of the moments acting on a body is called the resultant moment. Okay? So a very quick introduction here, right? Nothing too challenging, I don't think, for this video. So let's just jump into a couple of practice questions here. So let's get started with question 1. So let's get started here then with question 1. So as we can see then for question 1, we've got this diagram here. And this diagram shows a set of forces acting on a light rod. So the question then asks us to calculate the resultant moment about P here. So we've already mentioned it, right? But we do have a number of forces here. We've got this 4 Newton force acting upwards. We've also got this 2 Newton force here acting upwards as well. And then finally here, we've got the 6 Newton force acting downwards. So what we're going to do here to start off with then is find the moment of each individual force, and then we can go on to find the resultant moment here. So let's start then with the 4 Newton force here. So for the moment here of the 4 Newton force, so don't forget they're nice and straightforward here. This is simply the product of the magnitude of the force, which in this case is 4, times by the perpendicular distance then, which in this case is 2. So we get 4 times by 2 here, which is equal to 8. And don't forget the units here, right? So we're working in meters, so our units here are Newton meters, like so. And now we also need to state the direction of rotation here. So don't forget then the easy way to evaluate this here, right, is imagine we've got our finger here at P, and it holds this rod here in balance. And then we apply this force here of 4 newtons. So which way will the rod rotate here? Will it go clockwise this way, or will it go anti-clockwise this way? Well, in this case here, right, if our finger's holding the rod here at P, and we apply this force here of 4 newtons, so we push upwards here at this point, well, that would go clockwise, right? It's going to go in this direction here. So this is 8 Newton meters clockwise. So now let's move on to the moment here of the 2 Newton force. So now for the moment here of the 2 Newton force. Again, nice and straightforward here. This would simply be 1 times by the magnitude of the force, which is 2. I do 1 times by 2 here, which is equal to 2. So we get 2 Newton meters there. And again, we need the direction of rotation here. So if my finger's holding the rod at P and we push upwards here, then in this case, this would now go anti-clockwise, right? It's going to go this direction here. Okay, so it's 2 Newton meters anti-clockwise. So anti-clockwise there. And then finally, let's find the moment here of the 6 Newton force. So for the moment then of the 6 Newton force here, again, nice and straightforward. This is simply the product then of the perpendicular distance, which in this case would be 4. 1 plus 3 is 4. And then we times it by the magnitude of the force here, which is 6. So 4 times by 6 here, giving us 24 Newton meters here, like so. And now in terms of the direction of rotation here, if I'm holding the rod at P here, and I push downwards, this is going to go clockwise here, right? It's going to go in this direction. So it's going 24 Newton meters clockwise. Okay. So to find the resultant moment here, what we need to do then is state which direction is positive. So in this case here, right, given that I've got 8 Newton meters clockwise and 24 Newton meters clockwise, it makes sense to just choose clockwise as positive here. Okay. So choosing clockwise as positive. So choosing clockwise as positive here. Then in that case, what we get here is a plus 24 minus 2. Okay, so for the resultant moment then, let's just write this down. As we've just mentioned here then, that's a plus 24 because we've chosen clockwise as positive here. So a plus 24 minus 2 then, because this is anti-clockwise. So in that case then, anti-clockwise is negative. We get 8 plus 24 minus 2 here. That's going to be 30. So we get 30 Newton meters there. And that will be clockwise. Okay, because it's positive here. So 30 Newton meters clockwise there. And there we have it. So like you can see then, nothing too challenging here, right? Just work out the moment of each individual force. Choose a direction as positive. So it's either clockwise as positive or anti-clockwise. And then you can easily find the resultant moment by just considering the sum then of each force. Okay. So there we have it. That gives us the solution there to question 1. So to finish with here, then let's just take a look at one more question. So we've got question 2 here. And again, we're given this diagram. So this diagram shows a set of forces acting on a light rod. We're told that the resultant moment about P here is 6 Newton meters clockwise, and it wants us to find the length D here. So again, just to get us started here, all we're going to do is find the moment of each individual force. So let's start then by finding the moment here of this 4 Newton force. So the moment then of the 4 Newton force here. Nice and straightforward, right? This is simply the perpendicular distance here. So in this case, to go from this force to P here, that's going to be D plus 3. And then we times it by the magnitude of the force, which is 4. So we get 4 lots of D plus 3. So 4 lots of D plus 3 here. We're working in meters, so our units are Newton meters. And then in terms of the direction of rotation here, so if we're holding the rod here at P, like so, and we push downwards here then, and in this case here, the rod is going to rotate anti-clockwise. Okay, so it's 4 lots of D plus 3 Newton meters anti-clockwise here. Okay, so now let's move on and find the moment of the 6 Newton force here. So for the moment then of the 6 Newton force here, again, nice and straightforward by this point, right? This is simply the magnitude of the force, which in this case is 6. And we times it by the perpendicular distance here, which in this case is 3. So we do 6 times by 3 here, which gives us 18. We get 18 Newton meters here. And now in terms of the direction of rotation here, so if we're holding the rod at P here, and we push upwards at this point here, then the rod is going to rotate clockwise. Okay, so we get 18 Newton meters clockwise. Like so. And then finally here, we have the moment of the 2 Newton force. So the moment then of the 2 Newton force here. Again, nice and straightforward. So the magnitude of the force is 2. We then times this by the perpendicular distance here of 2 as well. So we do 2 times by 2, or 2 squared, giving us 4 there. I get 4 Newton meters. And in this case here then, if we're holding the rod at this point here, and we push downwards right, again, we're going to go clockwise here. We get 4 Newton meters clockwise here. Okay. So we've now found the moment here of each individual force. Okay, so we get 4 lots of D plus 3 Newton meters anti-clockwise. We then get 18 Newton meters clockwise. And then finally here, 4 Newton meters clockwise. Now, the question tells us that the resultant moment about P here is 6 Newton meters clockwise. And it wants us to find the length D here. So it's up to you which way you choose as positive here. And it doesn't actually matter whether you choose clockwise as positive or anti-clockwise as positive. I'm going to demonstrate that. I'm going to show you both ways of doing this. Okay. So let's start then by choosing clockwise here as positive. So clockwise as positive. Okay, so choosing clockwise as positive here then. Well, in that case, if we choose clockwise as positive here, we've got 4 plus 18 minus this then, because this is anti-clockwise, right? So remember, anti-clockwise in this case will be negative. I get 4 plus 18 minus then 4 lots of d plus 3 is equal to 6, right? So this is positive 6 because this is 6 newton meters clockwise here, and we've chosen clockwise as positive. So this is equal then to positive 6 here, okay? So let's just simplify the left-hand side here. So I get 22 minus 4 lots of d plus 3 is equal to 6 here. Subtract 6 off both sides and add this to both sides here. I get 4 lots of d plus 3 is equal to 16. Divide both sides by 4, right? So I get d plus 3. So d plus 3 is equal to 4. And then finally subtract 3 off both sides. And we find that d is equal to 1 here. So that's 1 meter, right? Okay. So that's if we choose clockwise as positive. So I did mention that it doesn't matter whether we choose clockwise or anti-clockwise as positive here. Let me just quickly demonstrate that. So if I now choose anti-clockwise here, so anti-clockwise now as positive, then in that case here, what I'm going to get is positive 4 lots of d plus 3 minus 18 minus 4 is equal to minus 6, right? Because this is 6 newton meters clockwise. But in this case here, then clockwise is negative. So we get 4 lots of d plus 3 minus 18 here minus 4. And that is equal to minus 6 here. Okay. So this would be minus 22. So add 22 to both sides here. I get 4 lots of d plus 3 is equal to 16. And again, we're at this point here, right? So the subsequent working is just going to follow in the exact same fashion. Divide both sides by 4. I get d plus 3 is equal to 4. And then finally here, subtract 3 off both sides. And we get that d is equal to 1 as well. Okay. So clearly, you don't have to do this twice, right? I'm just merely doing this just to demonstrate that either way is absolutely fine, right? So whether you choose clockwise as positive here or anti-clockwise, either's fine, and you should get the same answer either way. Okay. But there we have it. So we find the length d there, and that gives us the solution to the very last question, question 2. And that brings the end then of this video here on resultant moments.